In the following slides, I will show how to measure the output ripple as well as filter methods for the output side of a DC to DC converter. We see the oscilloscope probe with a long grounding lead. The high-frequency components of the common mode noise can be radiated and coupled to the oscilloscope ground clip. The effect can be seen on the left side. The high voltage spikes are coming from the common mode noise. The left picture shows a very good way to measure the output ripple. The long grounding cable was removed and a Johnson connector was added to the output of the DC to DC converter. On the right picture you see that the voltage spikes disappeared. The output ripple can be reduced by using some additional components such as extra capacitors, LC filters or more complex filter including common mode chokes. We added 4 low ESR capacitors to the output of this DC to DC converter. We can see the effect on the output ripple on the 3 diagrams below. The resolution is 50 millivolt per division. You also can see that the switching frequency changes with different output loads. On the left side you see a 10% load. The middle diagram shows 50% load. On the right side you see 100% load. Switching frequency increases with output current. You also can see that there is an effect on the ripple level. In this case we added an LC filter consisting of a 150 nanohenry choke and a 270 microfarad capacitor. You see that there is also a slight improvement on the oscilloscope plots below. Here we used a resolution of 20 millivolt per division. The QPAC concept is a very effective way to reduce the output ripple. A common mode choke on the output side together with the Y decoupling capacitors will reduce the common mode noise on the output side of a DC to DC converter. The parasitic inductance of the common mode choke builds an LC filter for the differential ripple. In our last example, we used the QPAC filter on the output side, common mode choke with 2 times 110 microhenry together with 1200 microfarad. On the scope plots below you see the effect. We have a resolution of 10 millivolt per division. I will show you the measurement of output voltage ripple of a DC to DC converter. Our device under test is a Vicor 200 watt DC to DC converter with an input voltage of 24 volt that is coming from an internal power supply and a 15 volt output that is loaded by an electronic load on the output side. In addition, we will bring in a few filters to improve the noise level. There will be 3 different types, a capacitor, then an LC filter and at the end a common mode filter. First of all, I would like to give you some hints how to measure the ripple. For this measurement I made some changes in my voltage probe. I reduced the length of the ground clip by removing the ground clip and adding a special measurement tool that I did by myself. So I made the length of the ground clip the same like the tip of the probe. The reason for this is I reduce the effect of common mode noise that can be converted into differential voltage and can be measured as output ripple. The first measurement will be the DC to DC converter without any filter. Load is 13.3 amps. This is nominal load. And the output ripple is about 214 millivolt peak. In most cases this should be enough, but there are several applications who need a better output ripple. So the next step will be to add an additional output filter. The first filter is a simple output capacitor, a low ESR capacitor with about 300 microfarad. I reapply the input voltage and bring in the output load, again the nominal 13.3 amps, and we see the improvement on the output side. I have to increase the resolution to get a better measurement. I switch to 20 millivolt per division. And the effect can be seen on the scope. It's about 23 millivolt peak, only with the 300 microfarad on the output side. The next step will be an LC filter that I prepared on a separated board. Here 2 times 6 microhenry inductance plus 150 microfarad output capacitance. So this will bring us a few additional millivolts in ripple noise. So 19 millivolt peak. A little bit better, maybe 18 millivolt peak on the output side of our DC to DC power supply. For special applications where I really need a very low output ripple noise, we can also add not only differential noise filter but also common mode noise filter. In this case I will use a common mode current compensated output filter that is also compensated for regulator stability. And you can see again the effect on the scope. It's very hard to measure now because it's so small. It's far below 10 millivolt. In addition, I would like to show you that we have an effect on frequency and as well on output ripple level when I change the load. Increasing the load will also increase the the switching frequency, as well as will reduce the output ripple.